I'm going to show you the application of trigonometry to solve distance problems when we have angles of depression. Look at this picture. This is a ship and this is an aircraft. The ship is on water surface and the aircraft is flying on the water surface above the ship. In the aircraft there is a pilot who is observing this ship. Now the problem is, if the pilot's eye is at an angle of depression of 50 degrees, and if the line of sight from the pilot's eye to the ship is 1,000 feet, then what is the horizontal distance from the ship to the aircraft, this place just below the aircraft, and also what is the height of the ship above the water surface? So this is how we are going to solve this problem. You need to construct a diagram similar to this, showing the position of the pilot's eye, the position of the ship, the line of sight from the pilot's eye to the ship, the horizontal line of sight of the pilot's eye, and also the height of the aircraft from the height of the aircraft from the ground surface, from the water surface, and the horizontal distance from the place just below the aircraft to the ship. After you have constructed this diagram, you need to label it. You may label this point H, and this B, and this M, and this C. The position of the angle of depression, which is 50 degrees, will be here. It is the angle between the horizontal line of sight and the line of sight from the pilot's eye to the ship. Once you get this angle, you need to find this angle, which is an interior angle of this triangle. You may call it triangle MBC. It is this triangle that we are going to use to find this distance MC, which is the distance of the aircraft to the ship. Now, to find this angle here, just take 90 degrees less 50 degrees. Why? Because this angle here is 90 degrees. The angle that is made by the horizontal line of sight and this vertical line is 90 degrees. Now, because we know this angle is 50, then we can find this angle by just taking 90 less 50 degrees. These are the calculations that you may use to find angle MBC. You just take angle HBM, which is 90 degrees, less angle HBC, which is 50 degrees, and you get 40, this angle here. After you have found this interior angle, then you need to apply trigonometry concepts to find the distance MC. Now, in trigonometry, we have this abbreviation. You may read this as SOTOKA, and this HAH. Looking back to this diagram, the relationship between this angle, this side, and this side is, this side is the opposite to this angle. This is the hypotenuse side to this angle. Now, because we have the opposite side, which we are looking for its length, and we have the hypotenuse side, then the ratio that we can use is sine. Sine equals to opposite over hypotenuse. So here we are going to use the sine of angle 40, this angle here. Sine of angle 40 equals opposite, which is MC, over the hypotenuse side, which is 1,000 feet. So sine of 40 equals MC over 1,000 feet. We may place this sine of 40 over 1 so that we can do the process of crossing multiplication so that we can get MC. This times this one is MC, and this one times this one is 1000 feet times sine of 40. The sine of 40 is obtained in the tables in the 4-figure mathematical tables, this book. Look at the natural science where there is angle 40 here. At the column labeled 0 minutes, you will find sine of angle 40 is 0.6428. So sine of 40 is written here 0.6428, or you may read it as 0.6428. If you multiply, you will get 64. This is 64.2.8, or 642.8 feet. That is distance MC. I am talking about this distance here, MC. And MC is now the horizontal distance from the aircraft to the ship. And this distance MC we are looking for is this distance, if you remember. Look back to this picture here. It is distance from here. It is the distance from here up to this point, just below the aircraft. The other problem, that was calculating the height of the aircraft above the water surface, is left for you to do it as a practice. Thank you.